this wonderful session. This is the A-level mathematics, and in case you have joined, yes, just feel free. We are going to go through some few things as far as pure mathematics is concerned. So prepare yourself, make sure you have a book, you have a pen, the calculator, then we can move on very well. So I think where we had stopped last time, we stopped on equations, where we looked at linear equations, looked at simultaneous equations, and then also we looked at the quadratic equations in pure mathematics. But at this moment, I would like to take you to another part of mathematics, which is known as the polynomials. Okay, so we are going to look at it. Just prepare yourself. You are going to enjoy. You know, mathematics is so enjoyable. So I think here what we are going to do, I'm going to be sharing some work on my desktop, so that I'll expect us to follow step by what? By step. So there we go. Let me try to get my work here. Yes, I think there you can be able to see the work. And with this work here, we are going to begin right from the what? From polynomials. So when you come to polynomials, it is not something very new. Okay, you can be able to see polynomials that we can write it down. I know, see, from primary you have been talking about polynomials, but indirectly, because you are not knowing. At that moment they were just saying equations, but now we can be able to characterize them. Remember, they have many types. We looked at linear ones, then you looked at also quadratic equations, but now all of them, they are polynomials, only that they differ in what? In degree. So let us go to introduction part. When you go to the introduction part, we are saying a function in the form fx, a function in the form fx equals a0 plus a1x plus a2x squared plus a3x cubed plus dash plus an x power n, okay, is said to be a polynomial in x. Okay, it is a polynomial. It is said to be a polynomial in x of degree n. Like there you can see this function. This function here, it is a function of x. That's why we are saying it is a polynomial in x. So it is a function of x and it is of degree n. When you check, look at the highest power on x. The powers of x, they are in ascending order. Here 0, here to power 1, here to power 2, here power 3, the next will be to power 4, then power 5, like that, up to power n. So the highest power of n in this function is n. So therefore, we are saying it is a polynomial in x of degree what? N. Degree, it is simply the highest power of x, which is in that what? In that function. And a should be equal to, should not be equal to what? 0. So when you look at this a0, a1, a2, a3, an, all these ones here, they are supposed to be what? constants. Okay, so these ones that are not supposed to be less, they are not supposed to be equal to what? 0. Otherwise, if they are 0, then we couldn't have such a what? A function. So it is only true that it is a polynomial in x of degree n when these constants are not equal to 0. So this is simply a general format of a polynomial function. Okay, so let us check out some examples of polynomials so that you try to differentiate them. Remember, we base on the degree. So let us go to this table here. We look at some examples. In the first column, we are going to have polynomial. In the next column, it will be the degree n of that polynomial. So let us go to the first polynomial. We have there x squared plus 2x minus 10 is equal to 0. So this is a polynomial. The question is, it is of which degree? So I told you that the degree of a polynomial, it is determined by the highest power of x in that polynomial. So when you check at this polynomial here, the highest power of this polynomial, the highest power of x in this polynomial, it is 2. So therefore, it is of degree what? 2. All right? That is for this polynomial here. The next polynomial, yes, look at this. The next polynomial we have 3x power 4 plus x cubed minus x squared plus 2x minus 3 is equal to 0. This is another polynomial. But the question is, it is of which degree? Check at the powers of x. What's the highest power of x in this polynomial? The highest power is what? 4. Therefore, we say the degree of this polynomial is what? 4. Let us look at another one. We have there x cubed minus x plus 30 is equal to 0. So this polynomial here, it is of degree what? 3. Yes. So here we are able to look at a polynomial and then we conclude what its degree is. Okay? So like the first polynomial, the degree is a degree 2. The second polynomial, it is of degree what? 4. The third polynomial, it is of degree what? 3. So that's how we can be able to look at a polynomial and then we write down its what? Degree. Now, let us simply also look at the first one. X power 5 minus 15x cubed plus 7x squared plus x is equal to what? 0. So this one is of degree what? All right? Just use like there we have recognized the upper ones. This one, it is of degree what? 5. Okay? So that is all how we can be able to write down degree of a polynomial. So allow me to move away from that. I've tried to show you how to come up with the degree of a polynomial. Okay? We simply look at a polynomial and then we look at the highest power on x in that polynomial. It's the one which leads us to the degree of a polynomial. All right. So those are some of the examples of polynomials. Let us go to operations with polynomials. Operations. When I talk about operations, you just know that I'm talking about addition of polynomials, subtraction of polynomials, division, even multiplication, okay? So we can be able to go to operations with polynomials. And let us begin with addition of polynomials. Addition of polynomials. So let us say, we are saying there that polynomials are added by adding like terms. Okay? Take note of this very, very well because some of you may be there making mistakes. We can add polynomials, but we can only do it by adding the like what? The like terms. For example, okay, let us look at an example. You add coefficients, okay? You add the coefficients of x cubed together. Are you seeing that? You add the coefficients of x cubed together. Like for example, I can say 2x cubed plus 3x what? Cubed. And what do I get? I get 5x what? Cubed. Okay? So we are supposed, when we are adding polynomials, we add ordinarily by adding the like what? The like terms. So i.e., the numbers multiplying x cubed. So here you may be confused what a coefficient means. When I say a coefficient of x cubed, I am meaning that number which is multiplying x what? Cubed. For example, when I say 2x, okay? When I say 2x cubed, its coefficient, the coefficient of x cubed is 2, okay? The coefficient of, I mean, when I say 5x power 2, the coefficient of x power 2 is 5, okay? So the coefficients of x cubed together, okay? The coefficients of x together and the numbers together, okay? So you have to add the coefficients. That's what we are looking at in this what? Step. So we are supposed to add polynomials by adding the like what? Terms. Let us try to look at the first example there. Add. Okay? They are saying add. Add 5x power 4 minus 3x power 3 minus 2x. 2, 7x power 4 plus 5x cubed plus 3x squared minus 2. So they want us to add these two what? These two polynomials. So how do we add? Remember, I said we add the polynomials by adding the like what? The like terms. So let us go to solution here. So what you are seeing here on your screen, I am firstly arranging my first polynomial. The first polynomial is 5x power 4 minus 3x cubed minus 2x. Now, remember their powers. The powers of x are in descending order. So I can write them down here, but in descending order of the powers of what? X. So I begin with the highest power, which is power 4. And that is 5x power what? 4. I write it here, followed by x power 3. And there it is negative 3x power 3. Okay? Negative 3x cubed. So I write also the way it looks, negative 3x cubed. Now, after x cubed, I am supposed to go to x squared. But in my polynomial, x squared is not there. So I can just write there a dash. If I want, I can write there a 0. Okay? Because x squared is not among these terms here in our polynomial. Now, after that, after x squared, I'm supposed to come to x. And here it is negative 2x. So I write negative 2 what? X. So I am supposed to write them in that order like that. And these are all the terms I have in the first what? Polynomial. Come to the second polynomial. The second polynomial, the highest is 7x power 4. That's the highest term also. So I write it just below 5x power 4. So 7x power 4 followed by 5x cubed, which is positive, and then followed by positive 3x squared, I think. So you write it in that, just below this dash here on the upper polynomial. Then after that, when you from x squared here, you come to x. But now in this polynomial, x is not there. So leave a dash. And then the constant is -2. So I end with -2. So I want to add. The reason why I'm doing like this is I'm trying to bring the like terms together and then I add them. Remember they said add. So when we try to add, the first terms 5x power 4 plus 7x power 4, we get 12x power 4. -3x power 3 plus 5 plus positive 5x power 3, we get positive 2x cubed. Dash or nothing or 0 plus positive 3x squared, we get positive 3x what? Squared. -2x plus nothing, we get -2x. Nothing here plus -2, we get negative what? 2. So here I'm trying to show you how to add polynomials. But this is simply ordinary. We have ever added this at O level, and we add after collecting the like what? Terms. So let us look at subtraction of polynomials. We are saying there that similar polynomials are subtracted by subtracting like terms. Okay? Just the same way we do when we are adding what? Polynomials. Okay? So similar polynomials are subtracted by subtracting like terms. So I'll not take you much on subtraction because it is just similar with addition. The process is the same. Rearrange your polynomial terms, then collect the like terms, then either add or subtract those like what? Terms. Okay? Right, let us go to multiplication of polynomials. Multiplication of polynomials, that when you multiply two polynomials, okay? When you multiply two polynomials, you multiply each term of the one by each term of the other. Okay? You multiply each term of the one or of one polynomial by each term of the second what? Polynomial. That is during multiplication. Okay? And all the resulting terms are added. Okay? Remember that when you multiply powers of x, you add the indices. So this is simply O-level work, which I'm trying to refer you to. Okay? Like you may be having x power 5 times x power 7. The answer will be x power 12. How are we getting 12? By using the other rule of indices. When you are multiplying the indices, you simply add their powers. So that's what we are supposed to use. So let us go to an example. It says multiply x cubed plus 3x minus 2 by x squared minus 2x minus 4. You see that? So they want us to multiply these two polynomials here. So when we are to multiply that, let us go to the next page. We see how to multiply. So now when you come to solution here, we are saying arranging this in columns so that it looks like an arithmetic or arithmetical log multiplication calculation. So you still rearrange like there we did during addition. So we rearrange there like this. These are terms of the first polynomial, and these are terms of the second what? Polynomial. But I told you you rearrange them in descending order, like that. And the first one, for the first polynomial, the first term is x cubed. It has no x squared, so you leave a dash like that. So you arrange them like that. Then what are we going to do? We are going to multiply, okay? So the first line here, what we are going to do, multiply top line by x what? Squared. Multiply the top line by x squared. So what do we get? You multiply, when you multiply x squared by x cubed, you get x power 5. X squared by nothing, you get nothing. X squared times positive 3x, you get positive 3x cubed. X squared times negative 2, you get negative 2x squared. Are you seeing that? So there we are multiplying the top line by x what? Squared. Next, multiply the top line by now next negative what? 2x. Okay? So when you try to multiply the top line by negative 2x, what is our first term which we get? We get negative 2x, okay, times x cubed, okay, which we get negative 2x power what? 4. We write it below this dash here. Then negative 2x times nothing, you get nothing. Negative 2x times positive 3x, we get negative 6x squared. Are you seeing that? Then negative 2x times negative 2, we get positive 4x. You see that? So we also multiply them like that. Then lastly, we come back and then we use negative 4. We multiply again by the top line. We multiply it by all those terms which are on the top line. So what do we get there? Negative 4 times x cubed, we get negative 4x cubed. Okay? Negative 4 times nothing, you get nothing. Negative 4 times positive 3x, you get negative 12x. And then negative 4 times negative 2, you get positive what? 8. So like that. And then after doing it like that, we are supposed to add them. Okay? We add them. Like here, it is going to be here, I think, x power 5. This one, it will be here, negative 2x power 4. This one plus this, it is going to be negative x cubed, like that. So when you add them, these are the terms which you what? You get. Okay? So this is showing how we can multiply two polynomials. So you only used to know that we can only multiply a function by like 2 times x squared plus 3. We used to just know that, but at this moment we should also learn how to multiply a polynomial by another polynomial. Okay, so that's what we are looking at. So this, if you have, I don't know whether you have a question, you can ask your question, then we proceed to division of polynomials, because this is simply multiplication of what? Polynomials. So division of polynomials, we can say that division of polynomials is usually set out rather like arithmetical long division. Okay? So here again we are going to see how we use long division to divide polynomials. Okay? Like the way I told you, math is so interesting. Only someone who is not learning math misses a lot of good things. But since all of you are here, yes, I hope you are enjoying. Okay? So let us first look at this example here, how we can divide what? Polynomials. But remember I told you we have to divide using long division. I know there are other methods, but for the beginning, I'm supposed to begin by showing you long what? Division. So divide. Example 1.3 says divide 2x cubed minus 3x squared plus x minus 6 by x minus 2. Divide. So when you say we divide this, how do we divide? Let us go to long division. By long division method, Yes, I know there. I'm going to write down, this is the divisor, okay? And then this is my polynomial, the function. I'm dividing 2x cubed minus 3x squared plus x minus 6 by, I'm dividing it by x minus what? 2. So if we are using Longo division, then we should write it down in this format. Such that, but now how do we divide? Because I know you since primary level, you used to know this method, but we never used to divide polynomials. But now, at the moment, we are supposed to see how we can also divide polynomials using this what method. Now, the first thing is, look at this. Look at the first term, okay? The first term here inside, it is saying 2x cubed. And then here, it is x. Now you ask yourself, what should I multiply this x by to get 2x cubed? Okay? What should I multiply x? What should I use to multiply x in order to get 2x cubed? My mind will tell me I am supposed to use 2x what? Squared. So let us use 2x squared to multiply this, and we see whether we get 2x cubed. I know we may get some other things also there, but I want to get here 2x what? Cubed. So let us see. Using 2x squared times 2. What do we get? We get here 2x what? Cubed. 2x squared times x, we get 2x what? Cubed. But you don't stop there. Also multiply it by, use this 2x squared, and then you multiply it by negative 2. So that you get negative 4x what? Squared. And when you reach there, since this term is the same as this one, then what do? We subtract. We don't wait. We subtract. So say that this 2x cubed minus 2x cubed, we get nothing here. Then negative 3x squared minus negative 4x squared. Yes. What do we get there? Negative and negative will become positive. So negative 3x squared plus 4x squared, we are going to get positive x what? Squared. Okay? So when I subtract this, I get nothing. When I subtract this minus this, I get this. But now, there are also these terms here which are left, which is positive x and negative what? 6. So what do? Lower them, okay? Lower them, okay? So that now, when they come down, they'll join this x squared so that it becomes x squared plus x minus 6. Okay? So you bring them down. Then after that, again ask your question, ask your mind, what should I multiply this x by? What should I multiply this x by to get x squared? What should I multiply x by to get x squared? Again, we say, let us use positive x. So that positive x times x, you'll get positive x what? Squared. Positive x still times negative 2, we get negative 2 what? X. Okay? So I have still used this x, which is positive, to multiply both of them. And after multiplying both of them, I'm getting this. Okay? I'm getting x squared minus 2x, like that. Now, after that, because now this term and this are the same, then the next thing will be subtracting. So x squared minus x squared, I get nothing. X minus negative 2x, I get positive 3x. But up here, I will be left with only a negative 6. So I'm supposed to lower it. I move it down. I move negative 6 also down to join to join this positive what? 3x. Then after that, again, you do this until the term here is less than. The power of x here is less than the power of x on the divisor. So now again, ask yourself, what should I multiply this x by to get 3x? We will say, let us use positive what? 3, like that. So that positive 3 times x, we get positive 3x. Positive 3 times negative 2, we get negative 6. Okay? Positive 3 times negative 2, we get positive, negative what? 6. Now, after that, when you try to subtract 3x minus 3x, nothing, 0. Negative 6 minus negative 6, we get 0. So meaning our remainder here, the final remainder of 0 means now the remainder which we are getting here is 0. There's no way that we can now divide in further. Rather, we stop there. Now the final remainder of 0, we are getting the remainder as 0. Means that x minus 2 exactly, or x minus 2 divides exactly into 2x cubed minus 3x squared plus x minus what? 6. So meaning x minus 2 is a factor of this function. Like it is the same as saying you are dividing you are dividing 10 by 2. 2 is a factor of what? 10. It gives 5 with no remainder. Okay? So this is what we are looking at here. Then another thing, the numerator here, that this is the answer, it is called the quotient. So after dividing, what we get up here is the answer or the quotient. That when you get this polynomial, this function divided by this function, you get this. This is the answer. And in pure mathematics, we call it the quotient. Okay? Then meaning that 2x cubed minus 3x squared plus x minus 6 divided by x minus 2. What is our answer? Our answer is x squared, 2x squared plus x plus 3. Simple like that. So when you divide this by that, this is the answer. Okay? And that is how we can be able to divide two polynomials, okay, using long division. So members, that is how we can do that. All right? Yes.